Hello everyone, good afternoon. Good afternoon students. Good afternoon Jayanti Babnagar and good afternoon Vijay. So you're from Jayanti Anand, right? Yeah. So students, am I visible? Can you able to see the screen? And am I audible? Yes? Yes or no? Can you able to see the screen? Let me know the answer in the chat box. Can you able to see the screen? Yes or no? Yes. Okay. So let's start with the today's session. So today, what we are going to do, we are going to solve some numerical problems from the topics that we have discussed till yesterday. Okay, so on the solutions lesson. Okay, so today fully we are going to solve problems from Henry's law, from concentration terms, and from the classification and the types of solution. So from these three topics, we are going to solve some problems, okay, which will be very, very useful for you for practicing. Okay, and you will be able to know that how to apply and how to get the correct answer and which formula has to be applied to which question kind of thing will be clear to all of you. Okay, so let's start with the first question. So the first question is the density of 2 molar aqueous solution of NaOH is 1.28 gram per centimeter cube. The molality of the solution is given that molecular mass of NaOH is equal to 40 gram per mole. So, what is given? First of all, try to find out the thing which is given in the question. So, the density of 2 molar aqueous solution. Okay. So, the density is given as 1.28. Density is equal to 1.28 gram per centimeter cube or gram per cc. Okay. And the concentration, if you see, it is 2 molar of sodium hydroxide and molecular mass is also given as 40 gram per mole. Okay, concentration is 2 molar for sodium hydroxide. We are asked to find out the molality. So what is the formula to find out the molality? What is the formula to find out the molality? So molality is equal to number of moles of solute divided by mass of solution in mass of solvent in kilogram, right? It is mass of solvent in kilogram. So this is the formula. So we need number of moles. So how to find out the number of moles of sodium hydroxide? It is equal to 2. It is already given in the question, right? It is 2 molar. We can take that as number of moles. So number of moles is given as 2. So moles of sodium hydroxide is equal to 2. Okay. Now we have to find out the mass of this solvent. But we are not given with any information about the mass. Okay. So how to find out the mass of the solvent then? So from the mass of the solution only we can find out the mass of the solvent. Okay. So we know that density is equal to mass by volume. And from this, what is mass? Mass is equal to density into volume. So this is the mass of the solution. This is the mass of the solution. First, let me find out the mass of the solution using density and volume given in the question. Okay. So the density of the system is 1.28. Okay. And the volume. So volume is 1 liter. Okay. 1 liter in terms of milliliter, it is 1000. Okay. So it is 1000. So 2 molar solution means what is the meaning? It is given in terms of molarity, right? So molarity means, so the 2 moles of solution is present in 1 liter of the solution. Okay. So it is 1000 ml. And if we multiply this, we will get 1280 gram as the mass of the solution. This is the mass of the solution. So mass of the solution is equal to mass of the solute plus mass of the solvent, right? Now we need this mass of the solvent. So how to get the mass of the solvent? So mass of the solvent is equal to mass of the solvent is equal to, so mass of the solution. So solution is equal to solute plus solvent. Solute plus solvent, and from this we are getting the solvent, which is nothing but solution minus solute. So the mass of the solution is 1280 minus solute mass. Who is the solute here? Sodium hydroxide is the solute. Okay. And its molar mass is 40 gram per mole. And we have 2 molar aqueous solution of the sodium hydroxide. So it will be 2 into 40, which will become the mass of the solute. So this is the mass of the solute and this is the mass of the solution. And we are subtracting these two and we are getting 1200 gram, which is equal to 1.2 kilogram. Okay. So we have got the mass of the solvent and we have the number of moles. So we can substitute directly in this formula and we can get the molality. So molality is equal to number of moles of solute, which is nothing but 2. So divided by mass of the solvent. So mass of the solvent is 1.2 kilogram. Okay. So it will give, has anyone got the answer for this? What is 2 divided by 1.2? 2 divided by 1.2? Has anyone got the answer for this? 2 divided by 1.2? Not even a single student has got the answer. 2 by what is 2 by 1.2? It is 1.67 molar. Okay. 1.67 molar, in which option D is the correct answer. Clear? So what we are asked to find out? The molality. So for molality, we need number of moles of solute. So that is given in the question. So we are getting the mass of solvent using these steps. From the density, we are getting the mass of the solvent from mass of the solution. That's all. So just understand how a problem is getting approached. Okay, so don't memorize anything. So just think what is required for the question and accordingly proceed with the steps. Okay, you don't have to memorize or you don't have to get scared of any question. Is that okay? So is this question clear to all of you guys? Shall I move on to the next question? Shall I move on to the next question? Are you all ready? So do any of you have any doubt from this question? Any doubt? If you're having any doubt, just raise your hand and ask your doubt in the chat box. And if there is no doubt, just let me know in the chat box with yes, so that I can move on to the next question. Or give me a thumbs up. So students, yeah, yes. Thank you so much, dear. So next, moving on to question number 2. If molality of the dilute solution is doubled, the value of molar depression constant will be. So actually, this is based on molality, but this question will mostly come under one colligative property. Okay. So this Kf, I'll give you the information about this Kf. So this Kf depends on the nature of the solvent and it is independent of the concentration of the solution. Okay. So Kf is dependent on, it depends on the nature of solvent, and it is independent on the concentration of the solution. So if the molality is nothing but the one of the concentration term. If the molality of the dilute solution is doubled, means if I am doubling the concentration of the dilute solution, so the molar depression constant will not get affected because it is independent of the concentration. Okay. So what is the correct answer? Option C is the correct answer. So it will remain unchanged. Okay. Clear? So Kf molar depression constant depends on the nature of the solvent and it is independent on the concentration. Shall I move on to the next question, students? Yes or no? Yeah, good. So moving on to the next question. Which of the following is dependent on temperature? Which of the following is dependent on temperature? Can you give me the answer? Yeah, one of you have given. C, A and A. So which one I have to take? A, option A, only A. Okay, very good. Very good, students. Molarity. Molarity is dependent on temperature. Yesterday we have discussed, right? Very good. So you are doing great. So you are JNV NM students, no? Yes, yes. Okay, good. So option A is the correct answer. So molarity is the concentration term which depends on the temperature. So that is the correct answer. Now coming to the next question. What is the mole fraction of the solute in a 1 molar aqueous solution? What is the mole fraction of solute in 1 molar aqueous solution? So how to find out the mole fraction here? The solution is there and we are asked to find out the mole fraction from the given information. So only one information is given to us, that is 1 molar. Molar, small m means it is molality. It is molality. So 1 molar solution means 1 molar solution means 1 mole of the solute is present in 1 mole of the solute is present in 1 kilogram of the solvent. 1 kilogram of the solvent. 1 kg is nothing but 1000 gram. Okay, it is present in 1 kilogram of the solvent because the formula for molarity is nothing but number of moles divided by mass of solvent in kilogram. No? So 1 molar solution means 1 mole of the solute is present in 1 kilogram of the solvent. Okay. So from this what we are getting? The number of moles of solute. So the number of moles of solute is equal to 1. Okay. So now how to find out the mole of solvent? The moles of solvent. So who could be the solvent here? The solvent is the water here. Solvent is the water. So number of moles can be calculated using given mass divided by molar mass formula. So what is the given mass? So 1 mole of the solute is present in 1 kilogram of the water, H2. So the given mass is 1 kilogram or 1000 gram. It should be written in terms of 1000 gram because the molar mass is given in terms of gram per mole, right? So we have to denote the mass in terms of gram. So I'm taking 1000 gram and the molar mass of water. What is the molar mass of water? We have 2 hydrogen. So 2 into 1 is 2 and we have 1 oxygen. So it is 16. So 2 plus 16 is 18. Molar mass of water is 18 gram per mole. Okay. So this is the moles of the solvent. Got it? Now to find out the mole fraction of the solute. Solute is component A and the solvent is component B. Okay. So to find out XA, it is equal to Na divided by Na plus Nb. So this is the formula to find out the mole fraction. Okay. So what is the number of moles of A? Number of moles of A means number of mole of the solute. So solute number of mole is 1 divided by 1 plus, and what is the number of moles of B? It is 1000 by 18. It is 1000 divided by 18. Okay. So we have to divide these two. So we will get 18 divided by 1018, which will be equal to 0.0173 Okay, 0.01768 or it is 77. So which is the correct answer? Option B is the correct answer. Okay, so clear? Any doubt? So do any of you have any doubt? No. Okay. So let's move on to the next question. How many grams of concentrated nitric acid solution should be used to prepare 250 ml of 2 molar HNO3? HNO3 is the nitric acid, okay? The concentrated acid is 70 percentage. Acid is 70 percentage of HNO3. So how many grams of HNO3 is required to prepare this solution? So what are the given values? We have the volume in terms of milliliter, and we have the concentration in terms of molarity, and we have the percentage of concentration. Okay, so since the concentration is given in terms of molarity, we have to go with molarity concentration term only to find out the number of, grams. Okay, so molarity is equal to number of moles of solute divided by volume of solution in liter. So number of moles can be written as mass divided by molar mass, okay, into volume in terms of liter. Okay. So if I'm writing volume in terms of milliliter, what I have to do? I have to put mass by molar mass into volume in terms of milliliter. But in the numerator, I have to put 1000. Okay. So we can write the volume in terms of milliliter like this. Now substitute all the given values in the formula. So what is the molarity? So this is the molarity. Molarity is the concentration, which is 2 given in the question, which is equal to mass. So mass only we have to find out. Grams means what? It is mass. So that we have to find out into 1000 divided by the molar mass of this HNO3. So how to find out the molar mass? So we have only one hydrogen and we have only one nitrogen. The atomic mass of nitrogen is 14 and we have 3 oxygen. So the atomic mass of one oxygen is 16. So if it is 3, 48. Okay. So it is 48. So it will be 63. So molar mass of HNO3 is 63 into volume in terms of milliliter is 250 ml. Okay. So if we cancel all these things, we will get the mass value as 2 into 63 divided by 4. Okay. So again we can cancel this. And what is the correct answer for this? So 63 divided by 2, it is around 45 gram concentrated HNO. Okay. So the correct answer is the correct answer is option D. Okay. So it is option D. Wait, wait, wait. So just wait. So here the weight is 63 by 2 gram, right? And weight of 70 percentage acid means, wait, I'll write here. The weight of 70 percentage acid we have to calculate. So sorry for that. I will let you know. So here 63 by 2 is the weight. 63 by 2 will be the weight there. And if you go for the weight of or the mass of 70 percentage acid, it will be equal to 100 divided by 70 into 63 divided by 2. Okay, 70%. We have to go in the other way around. So if you do so, you will get into 5. Okay, 5 into 63 or 63 by 7. You can go first. And what it is? One of you calculate and tell me. 5 into 63 divided by 7. Let's check whether we are getting 45 as the correct answer or not. 45, no? Yeah. So it will be 45. Then. So 45. Okay, so this is how we have to calculate. Then coming to the next question. 25.3 gram of sodium carbonate Na2CO3 is dissolved in enough water to make 250 ml of the solution. If sodium carbonate dissociates completely, if sodium carbonate dissociates completely, then the molar concentration of sodium ions and carbonate ions respectively are. So how to find out this? The given mass is 25.3 gram. Okay, so 25.3 gram is the mass of sodium carbonate. Okay, it is the mass of sodium carbonate and it is dissolved in enough water to make 250 ml of the solution. So 250 ml is the volume. And if sodium carbonate dissociates completely, then we have to find out this Na plus ion concentration and CO3 2 minus ion concentration. Okay, so here the answer is given in terms of capital M. So what is this capital M denotes? It denotes the molarity. So what is molarity? Molarity is equal to number of moles of solute divided by volume of solution in liter, or in terms of milliliter we can multiply this by 1000. Okay, so number of moles is nothing but mass by molar mass. So the mass is 25.3 and the molar mass of sodium carbonate we have to calculate. No, it is given in the question, right? So here it is given in the question. So 25.3 divided by 106 into volume is given in terms of milliliter. So we have to convert this into liter. So I am multiplying this by the number 1000 and here it is 250. Okay. So if we solve this, we will get. So can anyone solve this and let me know the answer in the chat box? One of you solve this and find out the answer first for the molarity. Then we can go for the remaining thing. One of you find out the answer. So take your time and find out the answer. Find out within 1 minute. So let's do it together, okay? Okay, let's check. Zero 0.955. All of you are getting the same answer? Okay, wait. Okay. 0.955 is the value. Yeah. 0.955. Very good. This is the molarity formula. So if sodium carbonate dissociates into Na plus, so we have what we have. We have to find out the concentration of sodium ion and the concentration of carbonate ion. Okay. So in the given formula, how many sodium ions are there? Actually, it is 2 Na plus and 1 CO3 2 minus. This is how we have to separate the sodium carbonate compound, right? It will be dissociated into 2 Na plus and 1 CO3 2 minus. Then only the charge will get balanced. So we have 2 Na plus, so it will be 2 into the concentration of this. So it is 2 into 0.955, which will be equal to 1.910 molar. Okay. And we have only 1 CO3 2 minus. So it is nothing but 0.955 molar. So now which is the correct answer? For sodium it is 1.9 and for carbonate it is 0.9. So option B is the correct answer. Option B is the correct answer. So it all depends on the dissociation only. If we have CaCl2, what we get? We will be separating this into Ca2 plus ion and 2Cl minus, right? Because fluorine is uni negative and this is di-positive. So in the same way, sodium will have only uni positive ion and the dissociation would be like this. 2 Na plus and 1 CO3 2 minus. Clear now? Shall I move on to the next question? Yes. Which of the following statements regarding the mole fraction of a component in solution is incorrect? You have to find out the incorrect relation about the mole fraction. Find out the answer first. It's very easy, no? Very easy and simple question. So try to get the answer immediately. Let's see who is getting the answer first. First. Day before yesterday, we have discussed about the mole fraction, no? So what will be the correct answer? Very good, very good. Very good, students. Option D is the correct answer. Why option D is the correct answer? Because the sum of the mole fraction itself will be equal to 1 only. Okay. So the mole fraction value can range from 0 and 1. That is, the x value ranges from 0, lowest value can be 0, the highest value can be 1. So it can never be equal to 0. Can never be equal to minus 2. It is never be equal to minus 2 or it is never be equal to plus 2. So that is the incorrect one regarding the mole fraction. Very good. So let's move on to one more question. The number of moles of oxygen in 1 liter of air containing 21% of oxygen by volume in standard condition is. So we have to find out the number of moles of oxygen first in 1 liter of air. Okay. So containing 21% of oxygen by volume in standard condition. So the percentage volume of oxygen. The percentage volume of oxygen is given as 21%. Okay. So what is the meaning of this? For 21% oxygen by volume. So it is mass by volume percentage concentration term, right? So it means 100 ml of the air. 100 ml of the air. 1 liter of air is given. So it is 100 ml of the air contains 21 milliliter of oxygen. Okay. Therefore, volume of oxygen. So we have to find out the number of moles of oxygen in 1 liter. So volume, let me find out the volume first. So volume of oxygen in 1 liter of air is equal to 21 divided by 100 into 1000 because it is 1 liter, no? So it is 1000. We have to convert this milliliter to liter, so I am multiplying by 1000. Clear? So it is given 21%, so that's why I have written 100 in the denominator. Okay. So now if I cancel this, what I will get? 21 into 10. It is 210 milliliter. So this is the answer for volume. But in the question, we are asked to find out the number of moles. So the number of moles is equal to in terms of molar volume is equal to the given volume. Number of moles in terms of volume is calculated using one formula. So that formula we did not discuss. Now here I am giving that formula. Take down that. Okay. So it is given volume divided by molar volume. It is given volume divided by molar volume. Okay. So now if I substitute the given volume, it is 210 milliliter. And in terms of milliliter, the molar volume value is constant and it is equal to 22400. Okay, 22,400 is the molar volume in terms of milliliter. Now, if we divide 210 divided by 22,400, what we will get? So, can anyone give me the answer? Can anyone give me the answer by dividing these two numbers? 210 divided by 22400. So, try the answer for this question. Number of moles is equal to given volume divided by molar volume. So two formulas we have seen no for finding out the number of moles. One is equal to given mass divided by molar mass. Okay, given mass divided by molar mass. So this formula you can use if you are given with mass values in the question. Option C 0.0. Okay. And one more formula is the given volume divided by molar volume. Okay, so note down these two formulas which are being used to find out the number of moles. So everybody has got the answer almost, no? So it is 0.0093. Very good. Option C is the correct answer. Very good. Next, coming to the next question. Which of the following modes of expressing concentration is independent of temperature? Tell me which one is independent of temperature. Normality and formality are also the concentration terms only, but that is out of our syllabus. So that's why we did not study about those things. Very good. Option B. Molality is independent of temperature. Yesterday I have given you the reason, right? Because molality is dependent on the mass of the solute, where mass doesn't changes with temperature. So molality is independent of temperature. Okay, very good. Now coming to the next question. The KH value for some gases at the same temperature T are given, where KH is the Henry's law constant in water. The order of their solubility in water is. So KH value is given and we have to find out the order of their solubility. Now you tell me which relation we have to use here to get the answer. Yesterday I have given you one relation. So tell me which one will be used here. What is the relation we have studied yesterday about KH and solubility? Can anyone tell me whether it is directly proportional or indirectly proportional? KH and solubility. Very good. KH is inversely proportional. Henry's constant is inversely proportional to solubility. So according to this relation, which one will be the correct answer? Option B. Very good. So option B is the correct answer. Very good, students. Very good. JMV Jalbon. Okay, good. So the one which is having the highest KH value is least soluble. So it is argon gas, right? Argon is having highest KH value among four. So that is least soluble. And then carbon dioxide with 1.6 and here 0.4 and here it is 0.0001. So very least, it is 10 to the power minus 5, right? So that is having very least KH value with more soluble. Methanol. Okay, good. Now moving on to the next question. So we have two lists and you have to find out the correct match. This question is from the classification and types of solution. So solid and liquid type solution. The example for this is, which one is the example? So we have four component in list 1 and we have 5 component in list 2. One is extra, so which will be out of our thing. So find out the example for first type, solid in liquid type. Has anyone got the answer for solid in liquid type here? Which one is the answer? 1, 2, 3, 4, 5. Among these 5, which was the correct answer? 4. No, no. Oh, you guys are giving me the correct option. Okay. Okay. So are you all saying the correct option? Okay, okay. Overall 4. Okay. So very good. Correct answer is option 4. Solid and liquid means sodium hydroxide is a solid and water is a liquid. So A goes to 5 and liquid and solid. So zinc amalgam. Okay, zinc amalgam is nothing but zinc mercury. Mercury is a liquid metal I have told you and zinc is a solid. So it is an example. And solid and gas type means, so camphor is a solid, right? Air is a gas. And gas and liquid is, gas is soda water. So carbon dioxide is dissolved in the liquid water, right? So it is an example for gas and liquid. Very good. Very good, students. Option 4 is the correct answer. Next, coming to the mole fraction. The mole fractions of water and methanol in a solution containing 1 mole of water and 4 moles of methanol are. Very easy. Find out fast. Find out the answer fast. Let me see who is getting the correct answer first. Find out the mole fraction of both the component. So take component A as water and component B as methanol. OM. So who is this OM? Is your full name OM, my dear? OM is giving the correct answer. Option 1, sure. Okay, so let's check. So the mole fraction of A is equal to number of moles of A divided by number of mole of A plus number of moles of A. So number of mole of A is 1. 1 mole of water divided by 1 plus 4 mole. So it will be 1 by 5, which is equal to 0.2. And next, coming to XB. Coming to XB, it is NB divided by NA plus NB, right? So NB, number of moles of B is 4 divided by 1 plus 4 again. So it is 4 by 5, which is equal to 0.8. So you can use the other formula also. So if you are getting the one of the mole fraction, you can use XA plus XB is equal to 1 formula also. Okay, so from this you can get XV, which is equal to 1 minus XA and XA is 0.2 and it is equal to 0.8. So using this formula also you can get the other one. Okay, so you don't have to multiply and divide each time, every time. So you can go with this also. So we are getting 0.2 and 0.8 as the mole fraction values for water and methanol, in which option 1 is the correct answer for this. Very good. Now moving on to the next question. The concentration unit which does not change with temperature is. The concentration unit which does not change with temperature is. JNB Yanam students have supernatural power, it seems. Giving the correct answer within a fraction of second. Very good. So keep the spirit till the end, okay? I want you to keep the spirit till the end. Good, good. Jane Vijal, good, good. So the correct answer is option 1. So both molality and mole fraction. We all know that molality is independent of okay, okay. Fine, fine. Good, good. Hats off to your sir. Hats off to your sir. Okay, good. So the concentration unit which does not change with temperature is both molality and mole fraction. Why mole fraction is also independent of temperature? You also know. Thank you so much. Thank you so much. Okay. So keep the spirit till the end. So in the next year, when you are appearing for your NEET exam and JEE exam, you have to get good marks and you have to come out with a good result. Okay. So that's all we all need from you people. Okay. So all the faculties from all the sides needs that only. Okay. So good. Both molality and mole fraction. So mole fraction is independent of temperature. Why? Because it is the ratio of two numbers. Okay. So it is just the number. It is not a variable. So mole fraction is also independent of temperature. So with this, the question session from the topics which we have discussed in yesterday. So that is getting over. So here I am going to end the class for today. So tomorrow what we will do? We will discuss Raoult's law. Okay, so we will discuss Raoult's law and following that we will go with the ideal and non-ideal solutions also. Clear? So is that okay? Is it okay for all? So we can wind up the today's session here. So meet you all in tomorrow's session. Okay. Thank you so much. Take care. Thank you so much for listening the lecture. Bye bye. Happy Ramzan. Same to you. Same to you. Happy Ramzan. Okay, students. Bye bye.